Alright, you are welcome again. Today we want to talk about scalar field and vector field. Scalar field and vector field. Let's take a look at this problem. Given that vector A is equal to x squared y I plus open bracket xy plus yz j plus xz squared k, and then vector B is equal to yzi plus 3xz j plus 2xyk, and then we have a scalar. Let's say 5 is equal to 3x squared y plus xyz minus 4y squared z squared minus 3. Now, the question says determine at the point 1, 2, and 1 the following: A, the gradient of file; B, del dot A, which is the divergence of A; then C, del cross B; then D, we have gradient of def A; then E, the coil of coil B. All right, yes. So please pay attention. This is what we are going to solve now and explain in details. Okay, now look at this. If a scalar function, let's say file of x comma y comma z, is continuously differentiable with respect to its variables x, y, z throughout the region, then the gradient of phi written grad phi is defined as the vector grad phi is equal to the partial derivative of this phi with respect to x on I component plus the partial derivative of this phi with respect to y on j component plus the partial derivative of this phi with respect to z on k component. All right, yes, we see that this phi is a scalar function, and grad phi turns it to a what? A vector. Grad phi turns it to what? To a vector. So therefore, we say that the composition or the operation we just performed now is called vector differential operator. It's called what? Vector differential operator. Look at this sign. We call it del or nabla. You see this sign? We call it what? Del or nabla. It is called the vector differential operator. The vector what? Differential operator. Now let's go to question A. We are asked to find del phi, or we simply say grad phi. Okay, so by definition of grad phi, we say that it is the partial derivative of phi with respect to x on I component plus the partial derivative of phi with respect to y on j component plus the partial derivative of phi with respect to z on k component. All right, since the phi is 3x squared y plus xyz minus 4y squared z squared minus 3. All right, so here we are going to find the partial derivative of this phi with respect to x, the partial derivative of this phi with respect to y, and the partial derivative of this phi with respect to z. All right, yes, when we find the partial derivative with respect to x, we are going to have 6xy plus yz. Okay, yes. Now when we find the partial derivative with respect to y, we are going to have 3x squared plus xz minus 8yz squared. All right, yes. Now when we find the partial derivative with respect to z, we are going to have xy minus 8y squared z. I'm very sure you know how to perform this partial derivative. Okay, yes. Now, the gradient of phi or grad phi, which we say it is the partial derivative of phi with respect to x on I component plus partial derivative of x with respect to y on j component plus the partial derivative of phi with respect to z on k component. So we have found the partial derivative of phi with respect to x, with respect to y, and then with respect to z. So with respect to x is on I component, we put it this way. With respect to y is on j component, we put it this way. And then with respect to z is on k component, we put it this way. So this is what we have. Okay, now let's go ahead. We said at a certain point. At a what? At a certain point. So here we find the gradient of phi at the point 1, 2, 1, which is telling you x, y, z. X, y, z, all right? X is 1, y is 2, and z is what? Is 1. So in this place now, anywhere we see x, y, z, we replace them with 1, 2, 1, all right? So when we replace, this is what we are going to have, okay? This is what we are going to have. So when you simplify this, we are going to have 12 plus 1 on I component, 3 plus 1 minus 16 on j component, 2 minus 32 on k component. So final simplification, we have that the gradient of phi at the point 1, 2, 1 is giving us 14i minus 12j minus 30k. It's giving us what? 14i minus 12j minus 30k. So this is for gradient of phi, which is number A. All right? Yes. Now let's go to number B. Number B says the del dot A. Del dot A. Now, let me show you something. Record the definition of this del, which is the gradient, okay? Now, we say that this del is the partial derivative with respect to x on I component plus the partial derivative with respect to y on j component plus the partial derivative with respect to z on k component. This is the del alone or the nabla alone, okay? Del alone, okay? So when you perform this operation on a scalar, the one we just finished now is on a scalar phi. We see it gradient of phi or del phi, okay? So that means we see the partial derivative of phi with respect to x, with respect to y, with respect to z on x, I, j component. But in this case, the del on its own, the operator on its own, it's giving you the partial derivative with respect to x, with respect to y, with respect to z on I, j, and k component. Okay, good. And then in this case now, we see that we have A is equal to x squared y I plus xy plus yz in bracket j plus xz squared k. All right, yes. In this case now, we have this operator dot the A that we have. Now this operator dot A that we have simply means the divergence of A. It simply means what? The divergence of A. Now let's go. This operator dot A, we put it this way. We have defined the operator and we have defined our A. So when you perform the dot product, I dot I, J dot J, and K dot K, what are you going to have? On I dot I, we are going to have the partial derivative with respect to x in bracket x squared y. Is that true? Yes. Now the next one, j dot j, we are going to have the partial derivative with respect to y over bracket xy plus yz. All right? Yes. Now k dot k, we have the partial derivative with respect to z over bracket x z squared. All right? Yes. Now look at this. Look at this. This one is telling you the partial derivative of this function. You see all this function in bracket. The first one, we are going to find the partial derivative of this function with respect to z, and then the second one, the partial derivative of the function with respect to y, then the last one, the partial derivative of that function with respect to z. Okay, so the first one, when we find the partial derivative with respect to x, we are going to have 2xy. Okay, good. Now the second one, with respect to y, we're going to have x plus z. All right, yes. Now the last one, with respect to z, we're going to have 2xz. We're going to have what? 2xz. Hello. All right, now let's go. This is the operator dot a, which we call it divergence of a, right? At a certain point, don't forget, at a certain point. What is that point? At point x is equal to 1, y is equal to 2, and z is equal to 1. We simply say 1, 2, 1. All right? Yes. This is what we have just found. We have just found, right? Yes, we substitute for x, y, and z. So doing so, we are going to have this. All right? So when we simplify, finally, we are going to have 4 plus 2 plus 2, which is equal to 8. All right? Yes, you see that we have the operator dot a, dot telling you scalar product. Telling you what? Scalar product. So finally, what did we have? We have a scalar, just a number, which is equal to what? 8. So here we have solved for A, and we have solved for what? For B. Now let's go to C. C is telling us the nabla or del cross B. The nabla or del cross B. Now recall that the operator del is giving us the partial derivative with respect to x, with respect to y, with respect to z on I, j, and k component. Right? Yes. And then also we have that b is what? B is equal to yzi plus 3xzj plus 2xyk. All right? Yes. Now let's go. Let's use matrix for the cross or vector product. For the cross product or for the vector product, let's use matrix. Let's use what? Matrix. Now let's go. Using matrix, we have ijk. That is the first row, right? ijk. Now the first one is our operator. We have the operator del, right? And then cross what? Cross B. And then you see that this operator, vector operator, is a what? Is a vector. Is a vector, right? Yes. This is going to be on the what? On the second row. So we have the partial derivative with respect to x under I, the partial derivative with respect to y under j, the partial derivative with respect to z under k, right? Yes. And then we have our b. Our b is having ijk, right? So the I for under I, the j for under j, and the k for under k. So we are going to have yz under I, 3xz under j, and 2xy under k. All right? Yes. In this case now, we are going to perform a cross product. We are going to perform a cross product. First of all, let's write plus minus plus at the top of the ijk. Okay? Yes. So let's pick the first one. I'm very sure you know how to perform cross product, right? Yes. Now let's pick the first one. We pick I, right? And then I is first row, first column. I is what? First row, first column. What you do is cover the first row, cover the first column. When you cover the first row, cover the first column, what do you have? You have the partial derivative with respect to y, okay? Then multiply it by 2xy. Then minus the partial derivative with respect to z, okay? Multiply by 3xz. Okay? Yes. When you cover the first row, first column, you have a 2 by 2 matrix. So you find the determinant of this 2 by 2 matrix. So this is what we just did. All right? Yes, we have the partial derivative with respect to y multiplied by 2xy, and then partial derivative with respect to z multiplied by 3xz. Okay? Yes. Now this is for the first one. Again, the next one we have j, and j is having negative, so we have minus j. J is in the first row, second column. First row, second column. So what you do is you cover the first row, cover the second column, cover the first row, cover the second column. So when you do so, you're also going to have another 2 by 2 matrix. Then you'll find the determinant of this 2 by 2 matrix. Okay, so the determinant is going to give you the partial derivative with respect to x multiplied by 2xy, okay, minus the partial derivative with respect to z multiplied by yz, okay, yes. Then we say plus the last one, we have k, and k is having positive, so we're going to say plus k. So k is in the first row, third column. K is in the first row, third column. So we are going to cover the first row, cover the third column. All right, cover the first row, third column. So when we cover the first row, third column, we have 2 by 2 matrix remaining, right? Yes, we find the determinant of this 2 by 2. So we are going to say the partial derivative with respect to x multiplied by 3xz minus the partial derivative with respect to y multiplied by yz. Okay, yes. Now let's go. In the first one, we have the partial derivative with respect to y multiplied by 2xy. So that means we are going to find the partial derivative with respect to y of these 2xy. So when you solve, it's going to give you 2x. Okay, yes, we have minus the next one. We have the partial derivative with respect to z of 3xz. So when you simplify, it's going to give you 3x. Okay, yes, minus j. On j, we have the partial derivative with respect to x of 2xy. So we are going to have 2x also. Then the next one, the partial derivative with respect to z of yz is going to give you y. So we have minus y, right? Yes. Then on k, we have the partial derivative with respect to x of 3xz. It's going to give you 3z. Okay? And then when we say the partial derivative with respect to y of yz, is going to give us z. Okay? So here we have I open bracket 2x minus 3x, which is going to give us minus xi, right? Good. Then we have minus open bracket 2x minus y, right? Good. And then the next one we have k open bracket 3z minus z. All right? Yes. Now let's simplify. In the first one, we're going to have minus xi. Then we say plus. The next one, we're going to have y minus 2xj. In this case, we use this minus j to multiply. So when you say minus j multiplied by 2x, it's going to give you minus 2x. And then minus j multiplied by minus y is going to give you positive y. That is why we have y minus 2x in bracket j. Okay, yes, we say plus. When you say 3z minus z, it's going to give you 2z. All right, yes. So you remember that this del cross b is at a certain point. Now let's find it at the point 1, 2, 1. So we have x is equal to 1, y is equal to 2, and z is equal to 1. So in this place, we plug in the values. Okay, so we are going to have minus open bracket 1 I plus we have 2 minus 2 open bracket 1 j plus 2 open bracket 1 k. Okay, so at the end of the day, we have minus I plus 2 k. We have what? Minus I plus 2 k. So therefore, this number C, where we have del cross B, which is telling us the coil of B, is giving us minus I plus 2k. All right, yes. Now let's go. Number D, we have grad dev A. We have to find grad dev A. Now let's go. First of all, what is dev A? Dev A is talking about divergence of A. It's the same as what we solved in number B, where we say the del dot A. We say is the divergence of A. All right? Yes. Now, where we solved, we have dev dot A. What did we obtain? We obtained 2xy plus open bracket, x plus z in bracket plus 2xz. All right. Yes, when we solved this divergence of A in number B, this is what we have, right? Yes. And then we see that this grad dev A is the same as saying this del, right? Dot, open bracket, del dot A is the same. Hello? Is what? Is the same. Now, in another way, you can say this one we just solved before, which is del dot A. Let's call it file, because on the normal is what? Is a scalar. Let's call it a file, right? So grad def A is telling us grad file, because def A is what? Is file. We just say let this def A be equal to what? A file, which is this del dot A, which is def A. Let's call it a file, right? So grad def A is equal to grad file. So that means we are going to find grad file, all right? And then grad file, the file we have here is del dot A. Is the same as divergence of A, all right? Yes. Now, by definition of grad phi, we say it's the partial derivative of phi with respect to x, with respect to y, with respect to z on I, j, k components. All right? Yes. Now let's go. In this case now, we have the file to be this 2xy plus open bracket x plus z in bracket plus 2xz. So when we find the partial derivative of this file with respect to x, we are going to have 2y plus 1 plus 2z. When we find this partial derivative of this file with respect to y, we are going to have 2x. And when we find the partial derivative of this file with respect to z, we are going to have 1 plus 2x. We're going to have what? 1 plus 2x. All right? Yes. So now, on I, j, k component, what is it going to give us? It's going to give us 2x plus 2z plus 1 on I component plus 2x on j component plus 2x plus 1 on k component. All right? We have the partial derivative with respect to x, with respect to y, with respect to z on x, I, j component respectively. All right? Yes. Now, remember that what we are solving is at the point what? 1, 2, 1. At the point what? 1, 2, 1. You remember the one we just carried and used now. We did not carry the final result because the final result just give us a normal number. All right? Yes. Now let's go. At this point, when we put this point, x is equal to 1, y is equal to 2, and z is equal to 1, what are we going to have? This is what we are going to have, right? When we simplify it, we are going to have 7i plus 2g plus 3k. All right? 7i plus 2g plus 3k. Now recall that we say that this divergence of A is phi. We say let's call this divergence of A to be what? To be phi. All right? Where we say grad phi is equal to gradient of that phi. So finally now we see that what we just solved is the gradient of divergence of A, which we say grad def A. All right? Is equal to 7i plus 2g plus 3k at the point 1, 2, 1. All right? Yes. Now let's go. The last one. We have coil of coil B. Coil of what? Coil B. Now we say that coil B is del cross B. Okay? Del cross B. That we solved in what? In our C. Okay? We just solved this in C. So what did we obtain? We obtained that del cross B is equal to minus xi plus y minus 2x on j component plus 2Z on K component. Alright? Yes. So now we'll see that this coil of coil B is the same thing as saying the del cross open bracket del cross B. Okay? Is that true? Yes. Now we have seen that this del cross B, we have solved it, right? Okay? Yes. Now let's call this coil B. Let's call it a name, or let's give it a name. Let's say it's equal to F. So when we say it's equal to F, that means we say that coil B that we have solved in C is equal to F is equal to minus xi plus y minus 2xj plus 2zk. Alright? Yes. Now let's also use matrix. Let's also use what? Matrix. But don't forget that this operator del is the partial derivative with respect to x, with respect to y, with respect to z on I, j, k component respectively. Alright? Yes. Now let's use the matrix method. Okay, so the matrix method is what we're going to have. We're going to have I, j, k, and then the del in the second row, and then our f on the third row. Okay, yes. So now let's go. Let's pick the first one. We have I. So we'll pick the first one, which is I. We cover the first row, cover the first column. So when you cover the first row, cover the first column, we are going to have 2 by 2 matrix. So we try to find the determinant of this 2 by 2 matrix. Okay, so when you do so, we are going to have the partial derivative with respect to y of 2z, right? Yes, minus the partial derivative with respect to z of y minus 2x, right? Yes, this is the first one. Again, we have minus j. Minus j will cover the first row, second column. First row, second column. So what do we have? We have another 2 by 2 matrix. So the 2 by 2 matrix is giving us the partial derivative with respect to x of 2z minus the partial derivative with respect to z of minus x. Okay? Yes. Now the next one we have plus k. So this plus k will cover the first row, third column. First row, third column. So as we cover the first row, third column, we're also going to have another 2 by 2 matrix. So this 2 by 2 matrix, we have the partial derivative with respect to x of y minus 2x, and then the partial derivative with respect to y of minus x. Alright? Yes. Now let's go. Let's simplify. So when we say the partial derivative with respect to y of 2z is going to give us 0 minus. When we say the partial derivative with respect to z of y minus 2x is going to give us also what? 0. Again, on this j, where we have minus j open bracket, we have the partial derivative with respect to x of 2z is going to give us 0. Then we have minus the partial derivative with respect to z of minus x is also going to give us 0. So here we have 0 minus 0, right? Good. Now the last one, on k, we have the partial derivative with respect to x of y minus 2x is going to give us minus 2. Okay, then we have minus, again, the partial derivative with respect to y of minus x is going to give us 0. So therefore, on I, we have 0 minus 0. On j, we have 0 minus 0 also. Then finally, on k, we have minus 2 minus 0. Alright? So finally, we have equal to minus 2k. Equal to minus 2k. Thus, the coil of coil B, or the coil B, is equal to minus 2k. Coil B, or coil of coil B, is equal to minus 2k. Yes, we have solved we are talking about scalar and vector product. We are able to find some different terms: gradient of file, divergence of a vector, and then also the coil of a vector. All right, yes, thank you very much for watching. Please, if you are new to our YouTube channel, please do well to subscribe, like, share our videos, and stay blessed. Let's take more examples. Let's go.